All right, if we start with a sine squared theta minus a cosine squared theta, and I look at my next step here, my next step, my numerator has turned into sine theta minus cosine theta times sine theta plus cosine theta. What happened? Yes. Yes, they factored it, right? Using, yes, and you could say using X method, or do you notice that this is a difference of two squares? Do you see the A squared minus the B squared in there, right? And a difference of two squares gets factored into the A minus B times the A plus B. So what they did on that first step was they factored the numerator. Everything that we did in algebra, we are going to use with our trig, okay? Everything is still the same when it comes to factoring. All right, so now that they factored that into the A minus BA plus B, so they factored into sine minus cosine theta times the sine theta plus cosine theta. What did they do from that? What did they do now to the next step? They're doing some crossing out, aren't they? They have a factor in the numerator and a factor in the denominator that match perfectly, so they are canceling. Okay. And then once they did that, where did they get their final answer? They just pretty much wrote what they had left, right? And what they had left was the sine theta minus the cosine theta. So this is the simplified form. So as I'm looking at tangent theta plus 1 over tangent theta, I go down to the next step. What process are they doing? What's in the second step that's not in the first one? Another tan. Do you see this right here? What are they doing? What are they doing? They're wanting to add these two expressions together. So what are they doing? They are finding the common denominator. Oops. Right? So let's say I have tangent theta, and I want to add that to a 1 over tangent theta. Well, I'm going to do what I said earlier. I'm going to make that one into a fraction as well. I cannot add fractions unless I have a common denominator, right? So I need to find my common denominator. So if I have a 1 here and a tangent theta here, what is my common denominator? What's going to represent both of those expressions? Tangent theta, and the 1 as well, right? But that's a given. We know that that is there. So what do we have to do? We have to go back and multiply with our special 1, right? And the special 1 in this case is that tangent over tangent, right? Because I've got to come over here and make this one good because I need that denominator, right? So that is what they're doing in this step. So when they multiply those two tangents together, they end up with what? The tangent theta times the tangent theta is going to give you what? Tangent squared theta, which is right here, right? There's your tangent squared theta. That's taking those two in the numerator. Tangent times tangent is my tangent squared theta. And then plus the 1. We're not going to change that second expression, right? Because it already had the denominator. All we're really doing over here is multiplying that top and bottom by the 1, right? So it's really not going to change anything. So when we go from this step to this step, what are we doing? We are just basically adding the fractions together. Okay? We're putting the two numerators over the denominator. So when we multiplied the tangent times the tangent, we got the tangent squared theta, and then plus our 1 that was already there. Now we're going to jump down to that next step. All right, so we have a tangent squared theta plus 1 in the numerator here, but now we have a secant squared theta. Where did the secant squared theta come from? Again, what's your thinking here? You see a square. What are you going to resort back to? You're going to resort back to your Pythagorean identities. So where did the secant square come from? Secant squared theta equals what? Tangent squared theta plus 1. So they are subbing in a Pythagorean identity. Okay. So now we're going to work with a secant squared theta over a tangent theta. Now we're going to come down here. Well, what they do from this step to this step? Where did the 1 over cosine squared come from? That's your secant squared, right? And then the tangent became sine over cosine. So we did two things here, right? We used reciprocal, right, identity, and we also used the quotient identity. In both cases, what did we do? We resorted back to turning everything into sine and cosine. So we used the reciprocal identity and the quotient identities. Or we could say that we resorted back to rewriting everything into sine and cosine. We resorted back to writing everything into sine and cosine. Okay, we're getting closer. Let's keep going. What color have I not used? Orange? Okay. All right, now, let's keep going. Okay, now what did they do from this step here to this step here? Yeah, we're changing it into multiplying, so we're going to multiply. Okay, so I have my 1 over cosine squared theta. I'm changing and flipping, so my sine over cosine becomes cosine over sine. All right, almost there. I'm out of colors. Pink? Yeah, I do have pink. Let's see if it shows up. Can you see it? Okay. All right, so now what did we do from here to here? We're just kind of now doing what? Are we kind of cleaning this thing up by doing what? Canceling. Yes, very good. So my cosines canceled. This one canceled and went to 1. This went to a power of 1. And then the 1 times 1 is the 1 over the cosine and the sine in the denominator. They kind of flipped them, but same thing. Since I have 1 over sine theta, cosine theta, I can do one more thing to clean that up. Let's go ahead and get rid of the, really the whole fraction, and we can turn it back into those reciprocals. Your cosecant is the 1 over sine and the 1 over cosine. So we'll end this by turning those back into using the reciprocal. Okay, and you're done. All right, so when I look at my first one, what is jumping out at me is this cosecant right here. That's what's jumping out at me. So what I'm going to do is I'm going to replace my cosecant with its reciprocal. So that would leave me with cosine theta, 1 over sine theta, plus 1 over sine theta. So I have a like common denominator, and I can add those numerators together. So I would have cosine theta times 1 plus 1, which would be 2 over my sine theta. I'm going to make this a 1 so I can over 1 so I know what's in my numerator and what's in my denominator. So now I see in my numerator I have cosine theta times 2, which would be 2 cosine theta over 1 times sine theta would just be sine theta. Okay? And I know that cosine over sine is really what? Cotangent. So I'm just going to replace that with my cotangent. Okay, there we go. Okay? Oops, I forgot my theta, didn't I? Let's go back and put them in. There's our theta. All right, now, let's take a look at our second one. I see a cosecant, I see a tangent. I'm going to change those. So I'm going to change my cosecant to my 1 over my sine theta, and I'm going to change my tangent to my sine over cosine. And my cosine, I'm going to turn him into a fraction to keep everything looking good there. Okay, then when I do that, I see, in fact, that my cosines will cancel. So those will cancel on out and become 1s. And what I'm left with now is 1 over my sine theta minus what? Sine theta over what? 1. So now this is the case of finding the common denominator. We did that on the strategy that we looked at earlier with the tangent. So what is your common denominator on this one? Sine. Sine theta and the 1, sine theta times 1, but the 1's not going to change anything here. So that means what I need to do is over on this side to get that sine in the denominator, I'm going to multiply top and bottom by sine theta. Technically, what we're doing over here is we're multiplying by that 1, but that won't change it. So let's put our common denominator down next, which will be the sine theta. And then the 1 times 1, we'll just leave it as a 1, and then minus. But when I multiply the sine theta times sine theta, what's that going to give me?
Sine squared.
Sine squared. All right, now, does 1 minus sine squared theta look familiar? Yes, it is what?
Cosine.
It is cosine squared theta. So I have cosine squared theta over sine theta. And I don't want to leave it as a fraction. I want to clean it up. I do know that cosine over sine is cotangent, but I will still have left over a cosine, right? So I'm going to rewrite this as a cosine theta, and then my cotangent. And there we go. Right, now that leaves us to our last one here. So the numerator, I'm going to kind of work the numerator out here. We have sine theta, so we'll do sine theta. I'm going to make him a 1. Over 1, sorry, minus my cosecant, and I'm going to turn that back into sine theta. We are going to do exactly what we did over here. We're going to find that common denominator and go back through and multiply. So now what I'm going to end up with is sine squared theta minus 1 over my sine theta. And then, of course, my cotangent is my cosine over sine. All right, sine squared theta minus 1 is opposite of what we need, right? We need the sine to be the negative, and we need the 1 to be the positive. What's that little trick I told you could do? I can factor out a negative 1, right? And then if I do that, then that will change all these signs, right? So let me come in with that. So if I factor out a negative 1, that would make my sign negative that I need and would make my 1 positive that I need. So then I could say that that is what? Negative cosine squared theta over my sine theta. And then my denominator of cosine theta, whoops, let me over my sine theta. And then to finish this up, we're going to take our division and we're going to rewrite it in as multiplication. So my negative cosine squared theta over my sine theta times my reciprocal, which would be the sine theta over cosine theta. And then now we can just do what here? Can we do some canceling? Cosines will cancel. This cosine squared would go to 1. All right, and the sines would cancel and go to 1. So what do we have left out of all of that? Negative cosine. Yes, thank you, Emily. Okay.